All right. So this is welcome to week 6 of NPTEL live session for digital signal processing. This is Sai Dinesh. I am the PMRF NPTEL TA for this DSP live session. Sorry, DSP course E33. All right. Alright, so this is the week 6 live session. So we'll be covering topics based on Z transform, initial value theorem and final value theorem, and next we'll be talking about the inverse Z transform. Basically we'll be talking about three methods for doing the inverse Z transform, and then I will be reviewing the assignment questions. Assignment of week 6 assignment. Okay. So the first topic is the initial value theorem. Initial value theorem. So let's say we have a left-sided sequence. So let x of n equal to 0 for n less than 0. Then x of z is can be written as x of 0 times z per 0, x of 1 times z per minus 1. Okay, so just write the general formula, which is minus infinity to infinity x of n z per minus n, where z belongs to a complex number. Can be written as e per j omega. So this is x of 0, x of 1 z per minus 1, x of 2 z per minus 2, and so on. So if we take the limit, so limit z tends to infinity, x of z is equal to limit z tends to infinity, x of 0 plus x of 1 z per minus 1, x of 2 z per minus 2, and so on. But as z tends to infinity, z per minus 1 tends to 0. So this will be equal to x of 0 plus x of 1 times 0 plus x of 2 times 0 plus so on, which is equal to x of 0. Therefore we state that limit n tends to infinity, x of z is equal to x of 0 if x of n equal to 0 for all n less than 0. Okay, so this is the initial value theorem. Okay, so let's take another scenario where x of n equal to 0 for n less than 1, a more lighter condition. So x of z is equal to now x of 1 into z inverse plus x of 2 into z per minus 2 plus so on. Now how do we get the value of x of 1? Here multiply with z. So z times x of z is x of 1. Is it recording? Satya, am I audible? Is my voice clear enough?
Correct, sir.
Okay.
It's clear.
Yeah, thank you. So z times x of z is equal to x of 1 plus x of 2 z per minus 1 plus x of z per minus 2 plus so on. So now we can get the value of x of 1 similar to the previous case, right? So if we apply limit z tends to infinity, z times x of z is equal to x of 1 yeah, x of 1 plus x of 2 x of 2 times 0, x of 3 times 0, and so on. Therefore limit z tends to infinity, z times x of z is equal to x of 1 if x of 1 equal to 0 for all n less than 1. Similarly we can do for x equal to 2 as well, where so limit z tends to infinity, z square x of z is equal to x of 2, and so on. So is this initial value theorem clear? So this is actually a very useful theorem actually. So whenever we have an x of z and we want to find specific values of x, the original signal, so if certain properties are satisfied, then it is actually it's actually very useful. So the next one is the final value theorem. Final value theorem. So for final value theorem, let's say let x of 0 equal to 0 for r n less than some generic m, right? Then limit z tends to 1, 1 minus z inverse of x of z is equal to x of infinity. So this again is a useful theorem. So the proof actually goes by let v of n is a signal which is the difference between x of n and x of n minus 1. Therefore v of z is 1 minus z inverse x of z. Now solve for limit z tends to 1 v of z. Upon solving we get that this is equal to limit n tends to infinity x of n. Therefore limit z tends to infinity, z tends to 1 minus z inverse times x of z equal to of infinity. So I mean I actually haven't gone through the details of the proof. It is there in the lecture notes. So this is the actual so this is the final value theorem, and this is the earlier one is the, so this is the final value theorem and this is the initial value theorem. So any doubts in this initial value and final value theorem? Okay. Okay, so in that case I'll continue with, so yeah, so this is the week 6 assignment. So I'll go through some questions from this week 6 assignment as well. Okay, so the first question, x of n equals 0 for n less than or equal to 3, then is z tends to infinity x of z finite? Assignment question 1 says that if x of n equal to 0 for n less than minus 3, right? In that case then x of c will be x of n z power minus n. So this z power minus n means that for negative values it is a positive power, right? So it will be like, so all of them are zeros, and then x of minus 2 z square, x of minus 1 z power 1 plus x of 0 plus x of 1 z power minus 1, x of 2 z power minus 2, and so on. Right, so here we have positive powers of z. So when we so now apply limit z tends to infinity x of z and check if it is finite. So if it is finite, right? So this is the first question. Is it clear? Okay, so let's do the question 2. So it says that if limit z tends to 1 minus z inverse x of z is finite, then what's the question? So then is what is then? That is the value of x infinity is limit z tends to 1 minus z inverse x of z equal to x infinity. Is this true? So hint is the final value theorem. So final value theorem, right? Now let's do the question number 3. Question number 3 states that if a sequence is not absolutely summable, then its DTFT is guaranteed to not exist. So it says that if the sequence is not absolutely summable, which implies summation over all n from minus infinity to infinity, absolute value of x of n less than infinity. But what is DTFT? N equal to minus infinity to infinity x of n e power minus j omega n, right? So check the condition. So hint is check the conditions under which DTFT exists. In which DTFT exists, right? So first 3 questions are done. So next I'll move on to another property which is known as the which I mean not a property, it's like a function. So basically, so it is any doubts up to this point? Okay, so multiplication in time domain. So let x of n and x of e to the power j omega be a DTFT pair, and similarly y of n then y e power j omega is a DTFT pair. In that case, then x of n into y of n, then x of n, so x of n into y of n equal to, sorry, is a DTFT pair with 1 by 2 pi minus pi to pi x of theta y of omega minus theta d theta. So this is equal to actually 1 by 2 pi x of omega convolved with y of omega, where this actually is circular convolution. So this is the circular convolution. So, and then the corresponding z domain property is x of n into y of n is a DTFT pair with 2 pi j s of r y of z given r into dr by r. So this is a contour integral. So we will talk about this later in the class, right? So a direct consequence of this theorem, of this multiplication property, is the Parseval's theorem. I mean Parseval's theorem, which states that summation over all n y equal to minus n, sorry, n equal to minus infinity to infinity, x of n y conjugate of n is a DTFT pair with 1 by 2 pi minus pi to pi x of omega y star of omega into d omega, right? So in particular, if x of n equal to y of n, then n equal to minus infinity to infinity, x of n square equal to 1 by 2 pi minus pi to pi x of omega square. So can anyone tell me why it is minus pi to pi here and not minus infinity to infinity? It's a basic property of DTFT. Can you tell me that? Hello? Sorry? Hello? Yes? Okay, so basically this is due to the periodicity of DTFT over 2 pi. So from minus pi to pi, and then DTFT repeats over the same, repeats after minus pi to pi. So like pi to 3 pi will be exactly similar to minus pi to pi. So that is the reason we take minus pi to pi and then a 1 by 2 pi term. So it's the basic property of DTFT. So this is the Parseval's theorem. So let's see an example of why this Parseval's theorem. So actually, if we say that, if you see this is equal to the norm of x of n. So let's say, so we'll use another notation. So this is the L2 norm square of x of p, and then this is this is this one. So this is the norm is preserved. So this DTFT is norm is preserved. It's a unitary transformation basically. Okay. So one example. Let's see one example. Okay. Find the numerical value of minus infinity to infinity 1.5 n 1.75 n by n square, right? And the value of sin alpha n by n for n equal to 0 is alpha. So we need to find the value of this the numerical value of this here. Can anyone give me an idea how to solve this? So this is basically, we can solve this using the Parseval's theorem. Can anyone give me an idea how to do this? Okay, so split this into 2. So here we have sin 1.5 n 0.75 n by n and by n, n equal to minus infinity to infinity. So this is equal to x of n, and this is equal to y of n, y star of n, or equal to y of n, since it is real. So x of n into y star of n. So how will this be equal? So according to Parseval's theorem, this should be equal to 1 by 2 pi minus pi to pi x of omega y star of omega d omega. Now if we take sin sin 1.5 n by n, what will be the DTFT of this? This is a sinc function. So can anyone help me what this the DTFT of a sinc function will be in the frequency domain? It will be a rectangular function from 1.5 pi by pi by to minus 1.5 by pi to 1.5 by pi. This is x e per j omega x1, let's say. And then for sin 1.75 n by n, so based on the previous one, this will be equal to minus 1.75 by n to 1.75 by n. So if we multiply these two, we'll have a common region which is again equal to this one, right? So if we do 1 by 2 pi minus pi to pi, so basically you need to solve this x1 x2 e power j omega, right? So this, I mean, once you have a common region, you just need to like solve this value, multiply, put this in this equation, you get the dt of t. So that this value equals to the actual value that we want, basically. D omega. So let's do the assignment question 4 now. So the power series expansion the power series expansion can be used for getting the inverse Z transform. Yes.
Sir, in the previous problem, you told me that for both the graph, the common region, no, sir,
Yeah.
1.75 and minus 1.75.
Yes. So this
So,
will be the common region. So if you
so that
see so if you multiply, I mean 1.75 will be like here, right?
yes, sir.
So if you multiply these two, this will be the common region left.
Yeah, yeah. So we need to take that range minus
Yes.
1 point.
Minus 1.5 to 1.5 and solve it.
Oh,
Clear?
okay, sir.
Yeah.
Mm.
Okay. So the assignment question 4, the power series expansion can be used for getting the inverse Z transform of both rational and non-rational functions. So for non-rational functions, it is quite clear. Like for example, if you have x of z of the form a k z per minus k from k equal to so minus infinity to infinity, so it is quite clear uh, to convert it to x of n. But then if you have a this is non-rational. So if you have a rational form, let's say x of z as 1 minus a naught z inverse, and then we have an ROC of mod j greater than mod a. So in that case, so this is a rational function. So can power series expansion be done here? Yes. How do we do this? Using long division method. So let's say like you have it here, right? So 1 minus a inverse, sorry, 1 minus a naught z inverse, and here it is a right sided sequence. So it should be of z inverse terms. So let's say we have multiplied by a z inverse. So it will be minus a z inverse, let's say. Um, z inverse, it will be a z inverse minus a z per minus 2. Oh, 1 second, sorry, cancel out. So multiply by 1, it will be 1 minus Az inverse. What will be left with this? Az inverse. So now multiply by Az inverse. What will be left with this? Az inverse minus A square z per minus 2. Again we get cancelled out, A square z per minus 2. So finally, so this will go as an infinite sequence. Then we can do the power series using power series expansion. Find IZT. Okay. Now question 5. Okay, so before I go there, I'll first tell you. First, I'll talk about inverse Z transform. Inverse Z transform. So it has three methods basically. So the first one is inspection method. So this is like pretty straightforward. You know a particular form of Z transform pairs, right? So you just apply it. You find the patterns in the X of Z of such form, and then use the Z transform pairs to find the inverse Z transform. Let's say like X of Z is 1 minus 2 Z inverse, and then ROC is OG greater than 2. So in this case it will be like two power n v of n, right? So this is one inspection method. So you know where 1 by 1 minus a z inverse will give a power n u of n. So these are the Z transform pairs that you already know. Using those we find the inverse Z transforms. This is pretty straightforward. So the next one is partial fraction method. This partial fraction method is when let's say x of z in the rest is of the form bk z per minus k by ak z per minus k equal to 0 to n, k equal to 0 to m. This is a rational function. So here we make it, let's say this can be made of this form where b naught by a naught. So you find the factors and change it into this form, like the product of factors equal to 1 to n dk z inverse, right? So here if m less than n, this will be equal to k equal to 1 to n ak by 1 minus dk z inverse, where ak is equal to 1 minus dk z inverse into x of z by z is equal to dk. So you have a rational form, convert it using the roots, you find it p of z by q of z, you find the product of roots in both the numerator and denominator, and then you split it up into partial fractions of this form. So this is the partial fraction method, right? So you from here you bring it here, and then to find the values of ak you do 1 minus dk z inverse times x of z, and then find the value at z is equal to dk, then you get ak. So this is how you do the partial fraction method. And then one more thing is the final method is power series expansion. Right, so power series expansion is x of z is equal to sigma x of n z power minus n. So if you have x of z of this form, it is pretty straightforward to find the x of n, where it will be like x of minus 2 z power minus 2 plus x of minus 1 z power minus 1, sorry, z square z power 1 x of 0 x of minus 1 minus 2, so on. So from here you get x of minus 2 x of minus 1 0 x of 1 x of 2 and so on. So this is the power series expansion, right? So let's do the now let's get back to the assignment. Let's do the assignment question 6. Okay, so let's say, so I'll do a similar problem, not exactly from the assignment, because assignment questions are not to be discussed. I mean, can't tell you the solutions for assignment questions. So x of z is equal to 2z square by 2z square minus 3z plus 1. So if you factor out z square common from both the sides and cancel them out, you will get 2 by 2 minus 3 z inverse plus z power minus 2. So this is of the form like x square minus 3x plus 2, right? So how do you do this? X square minus 6 minus 2x plus 2 x common x minus 1 minus 2 common x minus 1 x minus 2 into x minus 1. So how do we, so this will be of the form 2 by x minus 2 into x minus 1. So here, from here we need to find the partial fractions. So let's say this is equal to a1 by x minus 2 plus a2 by x minus 1. So how do you find a1? a1 equal to x minus 2 times xz, h equal to 2, which means 2 by x minus 1 into x minus 2, clearly x minus 2 a1 by x minus 1, sorry, to z oh. Z inverse z inverse z inverse z inverse. So this will be like 2 by 1 minus half z inverse and then 1 minus z inverse. Okay, so I factored out a minus 2 minus term, sorry, yeah, minus term and a 2 term in the first part, so of this form. So now this will be a1 by 1 minus half z inverse, a2 by 1 minus z inverse. So a1 will be 1 minus half z inverse into xz, h equal to 1 by 2, right? So what will this be? 1 by 1 minus 2, which is equal to minus 1. And then a2 will be 1 minus z inverse into x of z at z equal to 1, which is equal to 1 minus half into 1, which is equal to 2. Therefore x of z is 2 by 1 minus z inverse minus 1 minus 0.5 z inverse. So from here, can we find the x of n uniquely? Hello? Hello? Hello?
Yes, sir.
Can we find the x of n uniquely from x of z that we have here?
A power n u of n. So 2 into z by z.
2 into?
2 into u of n
Yeah.
minus 0.5 power n u of n.
So is this correct? So can you tell it is unique?
Sir,
Can you tell it is unique? Like if you have x of z, can you directly tell that this is equal to this? I mean this represents this.
actually the 1 by 1 minus 0.5 we can write z by z minus a, no sir. So z
Yeah,
by,
no. So the thing
so
is,
use,
so the conversion is right, but can this be unique? So can you say that this is the only solution to this?
yes sir.
No, actually I
Uh,
haven't specified the ROC here.
okay, yes sir. Yes.
Haven't specified the ROC. So this is not unique.
Yeah, yes sir. If we have
So
the
what are
with
the
respect to
poles?
RUC it changes.
Yes. So what are the poles here? 1 and 1 by 2.
1 and 1 by 2.
Yeah. So can you tell me the different ROCs that we have?
So both are positive. We'll be having the same value, sir. 2 into u of n minus 0.5 power n.
Yeah, that is true. I mean, what are the
So
different types
ROC
of
here is
what are the different types of ROCs that you get from these two poles?
ROC will be having the highest ROC 1 only, no sir.
No, no. So you have two poles here,
Yeah.
right?
So zero point 0.5 and 1. No?
Yeah, 0.5 and 1.
Mm.
So what are the different types of ROCs that you can have?
So low. So less than, greater than, and in between.
Yes. So z less than 1 by 2, and then 1 by 2 less than mod z less than 1, and then mod z greater than 1.
Greater than this.
Yes, exactly. So for this one, what will it be? For mod z less than 1 by 2, let's say. So
For
this
that we'll
one,
be having u of minus n will be
yes,
having
yes, exactly. So minus 2 into u of minus n minus 1
minus 1.
minus 0.5 power n u of minus n minus 1. For this one,
For this it is less than 1. U of minus n
u of minus n minus 1. But since this part, so since it is left
greater
sided
than,
to,
no, that is positive, sir.
yes, so
That will be u of n.
0.5 power n into u of n. For this one, both will be like minus 2 into u of n minus 0.5 power n into u of n. Exactly. So now it's clear. So whenever you have an x of z, you cannot directly write x of n. ROC should be mentioned. ROC is very important term. So I mean z transform cannot be, is meaningless without a ROC basically. Okay, clear?
Yes.
Okay. So now let's do the assignment question 7. So x of z is equal to 1 plus A inverse Z with ROC mod Z less than mod A. Okay, so mod Z greater than mod A. So we know that the expansion of log of 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on. So what will be the value of 1 plus A inverse Z? This will be A inverse Z minus A inverse Z whole square by 2 plus A inverse Z whole cube by 3 and so on, right? So once you have the Z square terms here, you can find out the x of n. This is pretty straightforward. This question is clear.
Yes, sir.
Okay, so question 8. X of z is 1 minus z power minus 10 by 1024 by 1 minus z power minus 1 by 2. So what is the value of 1024? It is 2 per 10 actually, and this is 2 per 1. So this is actually equal to 0.5 z inverse power 10 by 1 minus 0.5 z inverse. Can I write it like this? Okay, is this clear?
Yeah, sir.
Yeah. So now you do the long division method. So how do you do the long division method? You have, so here he has mentioned that the ROC is mod z greater than 0. So mod z greater than 0 means that it is right sided sequence. So right sided sequence means the coefficients will be of the form, like will have negative powers, right? So you have to divide accordingly. So minus 0.5 power 10 z power minus 10 plus 1. So let's say we multiply by 0.5 power 9 into z power minus 9. So this will be minus 0.5 power 10 z power minus 10 plus 0.5 power 9 z power minus 9. So these two get cancelled. So now what you are left with is minus 0.5 power 9 z power minus 9 plus 1. So next what do you multiply?
Actually, it's 0.5 per 9, is it not, sir?
Oh yeah, yes, exactly. Sorry, yeah, 0.5 per 9. So what do you multiply next?
It will be point for power 8.
Yes,
Z bar minus 9. How it is, sir? It's 8 only.
exactly, minus 8. So will it be, now it will be a minus 0.5 power 8 z power minus 8 plus 1.
It's 9
Sorry,
par 9.
sorry, plus 1 plus 0.5 power 8 z power minus 8. Again these two gets cancelled. 0.5 power 8 z power minus 8 plus 1, and then finally we keep multiplying them until we get a 0 remainder. Okay, so I mean we actually don't get a 0 remainder. I mean you just try it out and see what it is. So that is the part of the assignment. So once you do this, now we see that the coefficients are like 0.5 power 9 for the x of 9, 0.5 power 8 for x of 8, so on. So you need to like solve this completely, so you'll get the answer. Find x of n basically. Okay, clear? So question 9. let omega not equal to pi by 2, omega not less than pi by 2. Find the value of minus infinity to infinity sin omega naught n by pi n whole power 4, right? So we know that sigma x of n whole square has a dtft of 1 by 2 pi minus pi to pi xc for j omega d omega, exactly. So we have, so let's say x of n is equal to sin omega naught n by pi n. So this is a sinc function. So what will be the dtft of a sinc function on the in the frequency domain?
Rectangle.
Sorry,
Rectangle, sir.
yes, exactly. So it will be from minus omega naught to omega naught, the value will be 1. So sin omega naught n by pi n whole square is equal to minus pi to pi 1 by 2 pi xc per j omega whole square into d omega, right? So what is this value from here? 1 square, right? And this will be from minus omega naught to omega naught. So 2 omega naught by 2 pi equal to omega naught by pi. So now we got that the value of sin omega naught n by pi n whole square equal to omega naught by pi. Until here it is clear, right? So now let y of n is equal to sin omega naught by n by pi n whole square. So now we find the dtft of y of n, and then finally use the Parseval's theorem to solve for the final answer. Now we need to go to 2 power 4 to the power 4 actually. So again apply Parseval's theorem and the energy the unit the norm conservation, and then finally solve for final answer. This is the main part. After that you just do it one more time. You need to figure out what exactly it is. Okay, so this is the 10th question. So next is the question 11 to 14. It says that x of z is 3 z power minus 10 plus z power minus 7 minus 5 z power minus 2 plus 4 z power minus 1 plus 1 by z power minus 5 5 z power minus 4 plus z power minus 3. Okay, and in the question it is said that it is a right sided sequence, right? Said that this is a given it is the right sided sequence, so it is given in the question. right? So now actually one thing is you subtract, take out the do this simplification using what, using long division method. So you know it is a right sided sequence, so you should have something of the form which goes to negative powers of z, right, since it is a right sided sequence. So you divide the long division accordingly. And then 11th question, he is asking for x of 0. How do you find x of 0? We make use of the initial value theorem. So limit z tends to infinity, x of z is equal to x of 0. And then find, and another method is z terms x of z will give x of 1. So these are the methods, right? So 11, 12 thing for 13, and for 12, 13 also is exactly like done in the same way. Then or else what you can do is do the long division method. Once you do the long division method, you automatically get the x of n, from which you can derive x of 0, x of 1 and x of 2. Okay, so now the 14th question, the last question is, he said x e per j omega is equal to j omega. So sorry, one second, what did you say? H e per j omega is j omega for minus pi to pi. Using DTFT properties, compute the related sum. So what is x of n? 1 by 2 pi minus pi to pi h e per j omega n into d omega, which is equal to 1 by 2 pi minus pi to pi into j omega cos omega n plus j sin omega n into d omega. So now what you're left with is j omega cos omega n minus omega times sin j omega into d omega, right? So if we actually integrate this over the cos omega, it will actually go to 0. So what you're left with is 1 by 2 pi minus pi to pi minus omega sin omega n. Then again, since this is an even function, because of the negative term, 1 by pi 0 to pi omega sin omega n. So integrate this. Now solve the integral. You get that x of n equal to cos pi n by n for n not equal to 0 and 0 for n equal to 0, basically. So now what we need to solve is n equal to 1 to infinity 1 by n square, and then so let's say, so now we need to find, let's say we need to find x minus infinity to infinity. So this will be equal to 1 by 2 pi minus pi to pi cos square into d omega, which is 1 by 2 pi minus pi to pi omega square d omega, which will be pi square by 3. equal to 1 to infinity 1 by n square is equal to 1 by 2 equal to 0. 1 by n square, then this is equal to, so what is cos pi n equal to, it is minus 1, right? So if x of n square, it is equal to 1 by n square, exactly. So this is what you need to find, which is this one here. So you get the final answer, which is half of pi square by 3, which is equal to pi square by 6. Okay, yeah, so this is the end of the assignment questions. And then, so to summarize, so in this class we have discussed initial value theorem and final value theorem. We say that in initial value theorem, limit n tends to infinity x of z is equal to x of 0. Then final value theorem is limit z tends to 1 minus z inverse x of z is x of infinity. Okay, so we have done the assignment questions. And then next we talked about the multiplication property. Multiplication in time domain leads to the convolution in frequency domain. And then the next is Parseval's theorem, which states that the norm is preserved in both the time domain and the frequency domain. So L2 norm of signal square is L2 norm of the dt of t square. And then we saw some examples of how to solve them using these methods. And then we solve the rest of the assignment questions. So any doubts? You have any doubts in these concepts?
No, sir.
Okay, so yeah, so I mean I'll be here for a while. If you have any doubts, you can ask or you may leave, no problem.
Sir,
Yeah. Yes. Yes.
so actually in assignment week 5, can you explain any
Sorry,
answers?
you're
Can you please explain?
sorry, I can't hear you properly. Can you repeat?
Week 5, in week 5 assignment,
Okay.
week 5, sir, last week assignment. So we
Okay.
have some doubt
Okay.
if
One
that
second.
can be solved or not, I'm asking.
Yeah, sure. Week 5 assignment, right? One second. Yeah, week 5 assignment. Yes.
Last question.
Last. So minus 1 power ng of this one.
Yeah, last question. Yeah.
Okay. Let me see.
Actually, so
Sorry. Sorry. Or
actually we missed the marks assignment. So we didn't get the right. We didn't get the right answers for the assignment. So I'm asking you how to solve these assignments and marking.
okay. So we have what we have here is so I'll just take a screenshot and maybe explain it. See photos. Um. Okay, I'll explain it normally. So he said that. So the question is there are so 1 by 2 root 2 plus or minus j 1 by 2 root 2, right? The poles. So there are 4 poles, each of 1 by 2 root 2 plus or minus j by 1 by 2 root 2. Okay. So and then the question is, so this is a causal and stable system. So since it is a stable, since he is saying that it is a stable system, the unit circle should be involved, right? So unit circle involved meaning that the circle, I mean the RSA should be outside the outermost circle, right? Now g of n is exponential of minus j pi by 4n into h of n, right? So g of n is e power minus j pi by 4n minus j, right? Yeah, minus j pi by 4n into h of n. So according to the property, like the shifting property, so this is of the form e power uh, minus j pi by 4 whole power n into h of n. So of the form z naught power n into h of n. So if we take the z transform, it will be h of z by z naught, basically, right? Then here we have a, so this z naught is e power minus j pi by 4. So this implies the poles shift by minus pi by 4, right? So 1 by 2 root 2 shifted by angle pi by 4. So what is the uh, uh, angle of this point? So angle of this point will be 1 by 2 root 2 by 1 by 2 root 2 equal to 1, which implies theta equal to 45 degrees, right? Is this clear?
Yeah, sir.
Yeah. So when you shift it by minus pi by 4, the poles will be, sorry, so then now the new poles will be shift onto the on the real and imaginary axis, right? And then the magnitude of this pole this pole will be 1 by 2 root 2 square plus 1 by 2 root 2 square, which is equal to, what is it, 1 by 8 plus 1 by 8, which is equal to root 1 by 4 equal to 1 by 2, right? So now what will be the value of this? 1 by 2, and this will be 1 by 2j. Clear? So now the new h of z will be z power 4 by z minus 1 by sorry, z minus 1 by 2, z minus 1 by 2j, z plus 1 by 2, z plus 1 by 2j. Clear? Now the last question is, what do you want? Minus 1 power n. So what you need is n equal to minus infinity to infinity minus 1 power n into g of n. So what is g of z? G of n into z power minus n. So when will this be equal to this? It's equal to minus 1. Oh, 1 second. So what did he ask? Minus 1 power n into g of n. Okay, okay. No, it will not be. So g of n z power minus n. Sorry, so basically z inverse power n. So z inverse should be minus 1. So z equal to minus 1. Exactly. So we need to put g of z at z equal to minus 1. So this is, sorry, this is h of z. This is not h of z. This is g of z. Since we have used the new poles, so this is g of z, right? So after with the shifted poles, so now we need to find g of z at z equal to minus 1. So put simply like put z equal to minus 1 in this, and then you get the final answer. Clear?
Yes, sir.
uh, I mean, should I explain it once again, or was it clear? Yeah, so basically we know that e power minus j pi by 4, I mean, this is what we are multiplying with, and then when since z is equal, z naught is minus j pi by 4, poles are shifted by minus pi by 4. Now here we know that these are the values which have magnitude of pole to be 1 by 2 and at an angle of 45 degrees. So we shift them by minus 45. So now what we have is,
Yes. Hello.
yes, yes,
No, it is shifting it over by 4.
your voice is
It
breaking
has
a lot.
been so shifting a toll is big for pi 4.
Pi by 4 minus pi by 4.
P. Yeah. So it is from the question, sir. Exponential minus j pi by 4.
Yes, your voice is breaking a lot. Not able to hear you. Can you rejoin once again?
How do you see it?
Sir, she is asking that they are giving minus pi by 4 is not e power minus j by 4. So the poles has to be shifted like that, she is asking.
Yes, exactly. So So the new, so if we have it like this, and then so the ROC is mod 0 times the Rx. So if you have this, so this is of the form R e per j theta, right? So when you multiply with this term, basically, when this term power n, the poles are shifted by r and are shifted by angle theta. I mean the poles are shifted by magnitude r and by angle theta. So now if we have a power minus j pi by 4, it means that the poles are shifted by minus pi by 4. Usually, like if you have, let's say, g of n is 2 power n into h of n, in that case the poles will be shifted by twice. So 1 by the magnitude 1 by 2 will become magnitude 1, maybe like the 1 by 2 root 2 into 1 by 2 root 2 will, that will now become 1 by root 2 plus 1 by root 2. It's like that. So the shifting, so since we have a unit magnitude and a complex exponential, this will create a shifting actually. So now this angle, so like from here it will be shifted by that angle. Clear?
Actually, you have shifted that one, no? Because you got the root of 1 by root 2 that you are given a magnitude, is it not, sir?
Yes, 1 by 2
You,
root.
that is also the way to convert like this, no?
Sorry, so
Actually, you said no, minus 1 by pi by 4 is just shifting that poles by 45 degrees, is not.
exactly.
Actually, you got by that magnitude of p is nothing but root of 1 by that one you solve, no? That one.
Yes, so
You can do by that way also.
no, so actually we have the poles 1 by 2 root 2 plus j 1 by 2 root 2, and we
Yeah.
found out that these are existing at the magnitude of p is 1 by 2 and the
Mm.
angle of p is 45 degrees.
Ah,
So
okay, that's it.
yeah, regardless of what the positions of poles are, you shift it by minus pi by 2.
Okay, okay,
So like for example, if the poles are at, like for example, say 60 degrees, so
okay.
now the new position will be 15 degrees.
Oh, okay. Oh, 60 minus 45.
Yeah.
Yeah, okay, okay.
So this e power minus j pi by 4
Oh, okay, okay.
is
I
actually,
understood, understood, sir, understood.
yeah.
Actually, what we are getting the angle from that, we have to reduce
Yes,
e
whatever
power minus pi by 4.
the poles and zeros are shifted by the multiplication depending on the multiplication term here. Here if we have minus j pi by 4 means shifting by minus pi by 4. So all, I mean in the question the poles are existing at 45, so they go to 0. But if they exist at 60, they may go
60
to
degree it became 15 degree. Okay,
yeah,
understood, understood. Thank you, thank you.
yeah. Is it clear? No?
Yes, sir. Yes, sir. Yes, sir. Thank you.
Okay. So any other doubts?
No, sir.
Okay, yeah. So I'll be here. I mean, if you have any doubts, you can ask, or else, I mean, you can leave also, no problem.
Sir, thank you, sir. I'm leaving.
Oh, sure, sure. Sure, sure. Okay. Yeah. If you don't have any doubts, you can leave.
Okay, ma'am, bye, ma'am.
Okay, sir. So thank you so much, sir.
Thank you. Thank you.